And welcome back. So it's time for another presentation, time for an enthusiastic statistician with expertise in implementing machine learning tools for high-dimensional multiplex data structure. Droll Beryl, an independent statistical consultant, will share today insights and practical tips for leveraging the power of Teal in your data projects. We are going to see the world beyond pharma, clinical trials that can take advantage of Teal framework capabilities. Dror, it's your time to shine.
Thank you. My talk is about high-level, model-based R-Shiny apps with Teal framework, applications beyond the pharma domain. I'm an independent statistical consultant. These are some of the places I studied, taught, work, including here in Seattle, University of Washington, and the Freitas Cancer Center, and then moved into industry, eBay, Amazon, and more recently, doing consulting for pharma companies of all sizes. My background is I was trained as a statistician, so till today, my favorite terms are hypothesis, experimental design, experimental unit. Beware, I'm going to use them a lot in my presentation. I began my career as a SAS programmer, moved into S+. Here's a screenshot how S+ used to have a log of the code, which turns to be our code. I consider myself an early adopter of our web applications and used to play with it even before Shiny was a thing, with packages like Apache, Brew, Rook, and WebSockets. And then I use R for many other things, genomics, biomarker discovery, clicks, ads, IOs, and played in different disciplines, data science, real-world evidence, epidemiology. But at the end of the day, I'm doing descriptive, visualization, inference, aka machine learning, and causal inference. The outline of my talk are common challenges with Shiny web apps with emphasis on the scope or architecture of the app. Then I'm going to say why I love Teal. A spoiler alert, because it solved the common challenges. And we'll end up with a demo of non-clinical data. However, I am just one happy user. I'm not the developer of this amazing ecosystem called Teal, which is part of the Pharmaverse, as mentioned in a previous talk. Therefore, I'm going to present my own opinionated review. Speaking of Teal and Pharmaverse, they just released an amazing video for early users to be familiar with it, because it definitely could be overwhelming first time you click it. So make sure you look at this video for more detailed experience. So this is a typical day in my work. I get people dumped their data at me, and all kind of data sets, sources, databases, and they wish to get an insight out of that. That's where I'm here to help. So I like trained statistician with experimental units. So the notion of having observations in the rows, columns as variables, and values at the cells at the intersection of rows and columns makes sense, because this is preserving the experimental unit, subjects in the rows, or primary key, if you'd like. Therefore, part of the early steps I do with getting through this chaos is to annotate the dataset, understanding what are the tables, what are the primary keys, and try to make some order. To do that, I like to use object-oriented classes. One of my favorites is from the bioconductor community, an S4 class for summarized experiment. This is not the talking of my talk, so I'll go very briefly, but basically it has slots for the raw data here in the center. Columns are for the samples, rows are for the features or variables, and these are tied together, meaning that once I'm slicing them horizontally for the variables or vertically for the subjects, it's not going to slice only my data set, it's also going to slice my sample annotation data and my column annotation data. So the object-oriented makes sure that these are sliced together and I don't need to do those separately. Back before I used to do that, doing separately got me into all kinds of troubles, because probably happened to you, you filter or select one of the data sets and you forget to do it with your other data sets. That's chaos. And I also have a blog post about multi-assay experiments, which is taking this object into multiple layers. So why I like this? Because I don't need to do joins, and it's preserving the experimental unit. Not only that, I'm able to do meta-analysis. I dump my object-oriented in a table, in a nested table, and here my experimental unit is a study, which is a whole world. It has thousands of genes and variables and subjects, but I'm able to do it in a row-wise operations to extract the information I need. But this is not the topic of my talk. I'm going to talk about all kind of stuff I see that in Shiny apps, which are difficult. First one, unnecessarily data wrangling. For example, join subject-level dataset with non-subject-level dataset. This causes redundancy, which violates the experimental unit. Unnecessary pre-calculated repeated metrics for all possible combinations of covariance groups instead of using functions or models, which I'll present next, or parameterization, leveraging non-standard evaluation. Speaking of functions, all kind of convoluted functions, which are not focused, not isolated. And if I could sum it in one word, scope creep. Once your code has too many ad hoc patches to handle edge scenarios, if then, else, if then, maybe you are reaching out of your scope of your tool. So what is the Shiny model? Well, R is a functional programming language. We all use functions. We don't write functions from scratch each time. So simple question would be, why shouldn't we also use functions for Shiny functionalities? Why? Because these functionalities may be not so trivial. They come in pairs of UI and server to handle the input and the output. Luckily, we do have a solution for that. It's called a module. It's a pair of UI and server functions. So here on the left side, we have the traditional UI and server structure for the most simple Shiny app that have a select input, numeric input, and will present a histogram. And this is how we run the Shiny app. And on the right side, we have the model way of that, which is a function wrapping up around the traditional way. So here we have a function with parameter ID, same thing for the server with parameter ID, and the green bars represent that basically it's the same thing, just wrapped under some functions. And here, how we run it. What is this ID? This is, I call it the check-in, check-out. It's the identifier for the two components to know that they go together. Again, a pair of UI and server functions. Finally, what is Teal? And excuse me for my very simplified description. Again, Teal is a group effort by Pharmaverse, hundreds of developers and contributions. Previous speakers mentioned it started already in 2017, and it's now available for all of us to use. I define it as a collection of Shiny models plus a framework to assemble them in a coherent way. So each module is a pair of UI and server functions, and it's a collection of packages. And it comes with Teal modules General, Clinical, and Hermes. I will focus on the General because it's generic enough. It focuses on models for exploring relational and independent data. The other collections of modules are specifically for CDISC, which is data for clinical trial reporting, and my favorite S4 multi-assay experiment under the Hermes. My point is, even though those were designed initially for clinical data, let's see how we could use it with non-clinical data. So these are some of the general functions, models. Data table, simply present a table. Front page, general information, missing data, outliers, variable browser, cross table. I hope these are common tasks that you also do day to day. But not only that, we also have some statistical functionalities. Association, bivariate, distribution, response, scatter plot, PCA for principal components analysis, regression, and many, many more. And here's the magic. This is how easy it is to initiate the Teal framework. We use the init function, we use the data, which I'll describe next, and we list together the models. These models can be independent of each other. Some of them have parameters. Some of them are as simple as just the name of the ID. And that's it. We don't need to use the input and the output and reactive and observe event. These are all handled for us behind the scene. Let's look at the toy dataset. From the TV show Survivor, there is a cool R package called Survivor, which have information about anything you could think of related to this TV show. I will focus on two datasets. The first one is castaways. These are the participants, and this is what I call a subject level. So let's take one season, PG-44, Castaway. This is my primary key column, and it has one row for each of the participants, Bruce, Maddie, Heidi, and the episode that, and for each of these participants, we have the episode and that they caused with their end result. So for example, Bruce was voted out on the first episode, and Yam Yam was the sole survivor at the last episode. Another data set is challenge result. This is what I call event level. So here we have more than one row for each of our subjects, castaways. So for example, Bruce had two challenges. First one was Sea Critters, the second one was Paradise Lost, and he won the second one and lost the first one. Let's see how we tie these together. So here we have the two tables, and if we want to connect between them, both have the ID castaway. However, in the subject level, castaway is the primary key, and in the DF events, the primary key is a combination. The experimental unit is combination of castaway, challenge ID, and challenge type. So the question is, should we merge them? Maybe. I would say if I really don't have to merge them, so let's see how I could avoid it. So luckily, the Teal framework does not force us to join them. It will, however, ask us to define the keys similar way that we do those joins. So we just call the Teal data function with the name of the two data sets, and we defined the relationship without doing the join. The join will be done behind us in a safer way behind the scenes once we trigger the app. Before I showed you the app, beware of the T layout. It could be overwhelming for new users. We all used to this type of layout with UI on the left side, or maybe a sidebar. In the T layout, here on the right side, we have the deliverable at the center. So here is just a table, and we have UIs on the right side and left side. Left side is usually for the specific model, and on the right side is for the subject filtering. So here is my Teal Shiny app. I use just 6 models, so it gives me 6 tabs. First one gives me basic information. Second one gives me a React table, which I'm allowed to filter. And here I have one tab for each of the datasets. I will begin with DF subject levels. It's a total of 18 because this is the total of 18 participants that I have in the study. On the top right side, I have a summary of each of the datasets and observations on subjects. Subjects are the unique primary keys that I defined, and observations are not necessarily observations are rows in the dataset. Let's see how we filter them. Here on the bottom right, we are able to filter either by the subject level file or the event level. Let's click here, and we see Castaway. It comes with the magic key icon. I'm going to click on it, and it's going to populate subject level, which I could filter. I'm going to deselect all of them and pick only 3. Now the magic happened. I see only these 3 rows, and in my summary table, it tells me 3 out of 18 subjects. However, for the events, I have more rows than 3. So it tells me 3 subjects, but 47 rows. I switch here to the events, I scroll down, and I see 47 entries. I love it because I don't need to do those with joins. I don't need to be afraid that I accidentally missed filtering. It's all done behind the scenes for me. And I could do the same things with the second subject set, second data set, and magically it will not show me Castaway here, the primary key. Why? Because it is already been captured by the first table. This is another mechanism that knows that I'm not going to do horrible stuff. So here are other features built out of models with minimum effort for me to do, variable browser for me to set, missing data sets, and scatter plots. I'm able to capture these reports, give it a name, and save it for later, which now will appear in my profile, in my card report preview. I know this could be overwhelming, and that's why it takes time to get used to. How to link datasets to a model. This is a little bit more advanced. Some of the models, like the ones I use by default, take all of the datasets. Some of them expect you to use a single dataset. Some of them allow you to play with more than one dataset. For example, the subject level and the event level. An example is a swim lane plot. Here we have the bars for the specific subjects. So each bar is different participant. And we could color it and annotate it. And the event level are the dots here. So for example, if the challenge was immunity, so they had more than one. And so this was easy to use with a simple with a simple function. The original function, for example, had a geom point. I wanted to play with it and have it interactive, so all I had to do was overriding it and dump and replace it with a GGI graph. And so that's a nice way. You don't need to reinvent the wheel. You could take common things. So the pros, it's convenient, no joins, wide enough scope, doesn't need to worry about the nitty-gritty details. Cons are prefixed layout, not much, however, not much of flexibility on customize the layout, CS design, stuff like that. However, we hear the developers mention that they are working on that. And if you want to do that, yes, you might need to do some HTML from scratch. The trade-off, do you know enough on how to modify it for your own need? So I make the analogy to building a car. If you're doing it from scratch with at least 2,000 pieces, or maybe you feel comfortable taking some pre-assembled parts that should do the work just fine, but you may not know how to do those things from scratch as you need. While I love the Teal framework, it solved the most common challenges I see with my clients. No joins, preserve the multiple raw data sets, each at their own experimental unit level, models, functions for Shiny, specifically for the non-trivial UI functions. Makes obviating the low-level use of reaction, non-reactive observer events that's not very trivial. Support multi-omic bioconductor S4 objects, my favorite stuff. And community, that's priceless. I got stuck on something and I went on the Slack channel, and in less than 24 hours, someone helped me. That was priceless. So take home message, Teal is great. Give it a try. But Teal can also be overwhelming. So give it a try. Community is priceless. Experimental unit is a key. Unnecessary join merge may violate it. Scope matters. So keep it simple. How do you know you're in the good scope? Because things simple and you don't get into edge scenarios. Don't breach it. Choose a tool wide enough for your needs. And if you're not sure which tool, feel free to reach out. Thanks.
Thank you so much, Dror. We have a space for one question, and we take one from the chat from Kai. Great presentation. I agree. Did you write your own modules to complement with Teal modules in your Shiny app?
Yes, with the example of the swim lane plot, that was something that I was playing. It wasn't smooth and easy to begin with. There is still some hard stuff to do on the back because some of them are still connected to the C-disk data domains, but the community behind this tool gradually relaxing those and make it more general.
Okay. Thank you so much, Dror, for your great talk and sharing your experience and answering the question. Thank you so much.